You are welcome to this tutorial platform. I am instructor Victor. Now on today's class, I'm going to be teaching you on the formation of a differential equation. From my previous class, I was able to do justice to introduction to differential equation and solutions to differential equation. And today we'll be talking about formation of differential equation. And what do you know, or what can you understand from what we mean by formation of differential equation? This is how we can form a differential equation using a function of that a function of that equation which is given. Now for us to find a formation, or for us to form a differential equation, you are going to be differentiating as many times as there are arbitrary constants from that ordinary equation given. Now when you have two constants, you are going to be differentiating twice from the function you are given, and when you have one constant, you are going to be differentiating only once. These constants, I mean, they are the arbitrary constant. Now when you differentiate as many as the arbitrary constants on your function or the equation you are given, the last thing you will do is look for a way to eliminate those arbitrary constants. And when you are able to eliminate those arbitrary constants, you have formed your differential equation. And this constant, the more this constant, the more the order of your differential equation. Let's assume that you have one constant. The formation of that differential equation is going to be a first order differential equation. If you have two constants, the formation of that differential equation you are going to have is second order differential equation, and vice versa. Now I'm going to be using this example to enlighten you on how you can form a differential equation using this function. Now imagine you are asked to form a differential equation from the function y equal to x plus a over x. Whenever you are asked to form a differential equation, you must always have an arbitrary constant. And what is the arbitrary constant that we have here? We have a as an arbitrary constant, but the constant that we have here is only one constant. So we should be expecting a first order differential equation. Now solution to this example that I am using to explain the formation of a differential equation. You are given y equal to x plus a over x. Now you are given y equal to x plus a over x, and you are required to form a differential equation. Now what are the procedures that you are going to use now to form your differential equation? I told you, let me write procedure. Please, when you are writing exam, you have to follow these steps that I'm giving you now. You have to follow these steps. This step will make your work look very neat, look very tidy, and look perspective. Like the lecturer that is marking it will be understanding the point or the place you are talking about. Now you have a procedure. What are the procedures I have given you? I told you that if you have one arbitrary constant, you are going to be differentiating that function only once. If you have two arbitrary constants, you are going to be differentiating that function twice. But then here we have only one arbitrary constant, which is a, which means you are going to be differentiating only once. And then for us to differentiate, we have to arrange it in a better way. If you have y equal to x plus, now let us make this x a product of a, so that it will be in this form: a x raised to the power of minus 1 from our indices. If you have 1 over x, it is the same thing as x raised to the power of minus 1. Then you multiply it by a, you have a x raised to the power of minus 1. Now we will not differentiate only once because we have one arbitrary constant. Now when you differentiate, you will have here differentiating x with respect to differentiating the value of x differentiating y with respect to x. Now you'll be having here to be what? 1. And then when you differentiate ax raised to the power of minus 1, don't forget that your a is your arbitrary what? Constant. And the one of the what? Our formula for differentiation is if you have x raised to the power of n as our y. If you have to differentiate y, you are going to be having x, you are going to be having nx raised to the power of n minus 1, which means that that n that you have here, that value is going to come down, and then the n will what? Will reduce by 1. So if this value, which is minus 1, comes down here, this will change to what? Minus 1 times what we have here will still give us the same thing, minus a and then x. Now the power of this power or this index value will subtract by 1. Therefore we're having minus 1 subtracting by minus 1. You end up having minus what? 2. Now you have here, when you subtract this value here by minus 1, you'll be having minus 2. I'm sure that if you have reached this point of differentiating, you don't need to be learning all this one because they are very simple. Now what else are we expected to do? We have y prime equal to 1 minus ax raised to the power of what? Minus 2. Now what do? We will now come back to our equation 1. We will now come back to our equation 1, which is x plus a over what? Y equal a over x equal to what? Y. We will make a subject of the word formula. Subject of the word formula. Now, since we have made or we have used this particular format to aid our differentiation in a more simpler way, let us now bring it down again to its normal format, which is 1 minus a over x squared. I'm sure you are not confused on this. Now for us to move further, we have to go back to what? The function, which is equation 1, and then this is our equation 2. We have to go back to equation 1, which is y equal to x plus a over x. And for us to make our a subject of the word formula, so that we can come down to equation 2 and substitute, we will have to have some, we have to make something like this. Y, when this crosses this side, we have y minus x equal to a over x. And therefore when you multiply both sides, you having a equal to x of y minus x, something like this. So the value of your a is x bracket y minus x. Now come down to equation 2 and substitute for the what? Value of what? A as what? X into bracket y minus what? X. So when you come down here, you have y prime equal to 1 minus our a is what? X into bracket y minus x over x square. Now what do? You have x here, you have x square. Let it cancel and we still have another x left there down. Therefore we are going to be having y prime equal to 1 minus y minus x all over x. Because when you cancel this and cancel this, one of these will remain. Don't forget that it is what? X squared. Now you'll be left with y prime equal to 1 minus y minus x all over what? X. Now what else are we going to do? Let us shift this to this particular point, and we have that y prime plus y minus x all over x is equal to 1. Now let us collect LCM, or to add this together. We are going to be having x divided by 1 will have x times y prime will have x y what? Prime, plus x divided by x will have 1 times this, you will be having y minus x equal to 1. And then lastly, let x multiply this, and then you have that xy prime plus y minus x is equal to x. is equal to what? X. Now we now have that xy prime plus y minus x. When this causes usual part, we have minus x equal to 0. And then we have that xy prime plus y minus 2x is equal to 0. Therefore, this is a first order differential equation, and this is the formation of the differential equation from the function y equal to x plus a over x. So this is how you can solve and form a differential equation using a function that involves an arbitrary constant. Thank you for watching.